scared you. I was wondering why she was laughing.
Because she made the scared face.
Why would I want to get trapped over here? Then I'd be like,
No, you could have been like that over there. You're looking over that side. Actually, I just realized.
why would a grizzly bear run into my friend's house?
No, I was kidding.
Thank you, Steve.
You going on the futsal today?
No.
No?
All right.
Why not? I saw Bella say, he's like, I'm gonna go.
Lucas has a basketball game.
What?
I did not.
Lucas?
Oh, Lucas has a basketball game.
All right. Quiet back down, please. So, DJ came up, wrote the interpretation. I'm going to zoom in a little. Our expected value was 1.3. So we would interpret that as we would expect him to sell 1.3 cars in a month. Tanner's going to come interpret standard deviation for us. Zoom out a little. Sorry. That way, if you move it, it's not out of sight. Is it dead again?
No.
Oh.
When it dies the other day.
Gotcha.
It loses memory. And so it lost Pac-Man. So I can go read that with Pac-Man.
Or you could, just use your calculator for math. Or is that too boring?
Yeah, it's yeah. Well, what about when I'm done with the math and I'm waiting for everybody else to do it? And I play Pac-Man. So you can't get my phone out.
Thank you, sir. All right, so standard deviation, he interpreted our 1.0536 as the number of cars sold by Wilcox will vary by 1.0536 from the mean. Today, we're going to look at continuous random variables. We will be using our calculators a lot, so does anybody need to borrow one? And I'm going to ask you to go way back in your brains, back to chapter 2 again, because this is going to remind you of some of those problems. So before we get into the actual problems, we're going to define a continuous random variable a little more than we did on Tuesday. So a continuous random variable has an infinite number of outcomes with no gaps. So unlike the number of cars sold, which we can only sell one car or two cars, continuous random variables have no gaps. So on Tuesday I said height was an example. Somebody could be 60 inches or 60.1 inches, 60.15 inches. We could get even more specific about a person's height, so we have no gaps. Another example is weight. So we're going to define X as the weight of a 3-year-old girl. And X is going to be continuous because we can get really specific down to ounces and parts of ounces for a person's weight. Now, the weights of 3-year-old girls follow a normal distribution. They have a mean of 30.7 pounds and a standard deviation of 3.6 pounds. Can we make a probability distribution?
No. Yes.
Which one? No or yes?
Yes. What's the correct answer?
Maybe.
Perhaps.
You're gonna tell
No,
us.
yes, maybe.
Maybe.
All right, here's our probability distribution for the number of cars that Wilcox sold. Can we make a table that shows all the probabilities for every single possible weight of a 3-year-old girl?
No.
No. So instead of a probability distribution, we're going to make a density curve. And back in chapter 2, we worked with a special kind of density curve. What was that curve called? A normal curve. Thank you, Lindsay. So, with a normal curve, you're going to get really good at drawing them again. It's been a while. Remember, we draw our line, and then you're going to make the bell curve as best you can. When we draw a normal curve, what do we label them with? Anybody ever remember?
The mean and standard deviation.
The mean and the standard deviation. So we put a capital N. That tells us it's normal. And then in parentheses, we put our mean and our standard deviation. Now, up here, I told you that the weights of 3-year-old girls follow a normal distribution with a mean of 30.7 pounds and a standard deviation of 3.6. So we're going to use that information to get our curve a little more specific. So we're going to put the N, the mean is 30.7, standard deviation is 3.6. Then we're going to label this. So what goes at the middle of the curve? 30.7. Thank you. Our mean goes at the middle. How many dashes or hash marks above and below the mean should we label? 3. So we're going to go 1, 2, 3. 1, 2, 3. And then how do I find the numbers that go on those hash marks? I'm going to add 3.6 to 30.7 for the 3 above. For the 3 below, I'm going to subtract. Thank you, Jillian. All right, it's Friday and my brain is not working. 30.7 plus 3.6, that's 34.3, and then I want to add 3.6 to that one and that one. So the 3 above our mean are 34.3, 37.9, and 41.5. And then we're going to do the same thing, and we're going to subtract. So 30.7 minus 3.6, and minus 3.6, and another one. So we have 27.1, 23.5, and 19.9. Any questions before we start filling in this stuff on the side here? All right, so total area under the curve is what?
1.
1. So if we want to find the probability that a 3-year-old girl, X, weighs less than or equal to 28 pounds, we need to find the area under that part of the curve. And remember, we would put our boundary line. So our boundary line is going to be 28, which is going to be closer to the 27.1 than the 30.7. So like here-ish, that's 28. And we're looking at the probability that the girl weighs less than 28 pounds. So we're going to shade everything to the left. Now I'm really going to test your memory. Anybody remember the calculator function? Normal CDF. Thank you, ma'am. So we're going to use normal CDF to find the probability that the girl weighs less than 28 pounds. Annika, do you happen to remember the buttons to press to get there?
What are the numbers on? Stat, count. That might be wrong.
That is
Second bars.
second bars. Thank you, thank you. And then down one. So second bars, bars is next to clear. And we want the CDF, not the PDF. So like Jillian said, we're going to go down one to number 2. Now, if you have the older calculators, it doesn't prompt this. For those of you that have newer ones, it will prompt you to put in the lower bound, upper bound, mean, and standard deviation. Since we're looking at X being less than 28, we don't technically have a lower bound. We use the really small number that my calculator defaulted in there. Do we remember how to get that E if we need to type it in?
Second, comma.
Second comma. Thank you, ma'am. So for the lower bound, we want to put -1, and then we're going to do E, so second comma 99. That gives us a really small number. And then our upper bound, that's our boundary line we drew in the picture, so that's 28. And then the mean is 30.7, and our standard deviation is 3.6. If you have the older calculators and it doesn't prompt you, make sure you put the commas in between the numbers. Hi, Bianca. Everybody good? Can I hit paste? Good, Jenica?
No, we're good.
Okay. So when I, excuse me, hit paste, it puts into the home screen for me, and then we're going to hit enter, and we get 0.2266272794. How many decimals do we go to?
3,
4.
4. Why?
4. That's a really good question, Seth. I don't honestly know, but if you were to do it the old school way, using table A in the back of the book, they always have area go to 4 decimals. So even with calculators, they want... I don't know, okay? I didn't come up with the rules, I just teach them to you. Alright, so normal CDF. Remember, you also need to write down what you put in your calculator. You can't just give an answer. If you just give the correct answer, you'll get partial credit, but you'll lose credit for not putting what you put in your calculator.
Why do we have to tell you what we put in the calculator?
So it has to do with the AP exam. I because it's an AP class, I teach everybody the same as if they're going to take the AP exam, whether or not they really are. If you do not write the calculator information on the AP exam, you get 0 credit.
Well, that's dope.
If that's not for college credit thing.
That'll be the end of this month or the beginning of February.
If I got the correct answer, that means I obviously put in the right things in the calculator.
Or you looked at your neighbors.
That's true, but it doesn't. But if
You think
they
someone's
put it,
cheating?
they also put the calculator things, and I would put the calculator.
Would you?
Maybe.
It's how they grade the AP exam. So I just teach it that way. So if somebody takes an AP exam in my class, they're prepared to do it the correct way. So, all right. So we found the area under the curve. Couple clarifications back up here. The probability that x is less than or equal to 28. Do you guys think that's equal or not equal to the probability that x is less than 28?
Equal to,
Equal. It's equal to. Do you know why it's equal to?
because x equals 28 equal to 0.
The probability that x equals 28 is 0. Do you know why?
Because it would be an infinitely small amount.
So remember, the probability comes from finding the area under the curve. If we look at just x equals 28, that is a straight line. Do lines have 2 dimensions?
No.
So can we find area?
No.
No. So a line has no area,
Yes.
therefore the probability that x equals a exact number is 0.
It's like
So-
the chance of a 3-year-old girl being exactly 28.0 repeating pounds is 0%.
All right. And then we will be working with normal curves, but remember, not all density curves are normal curves. There are other types out there, but we will spend most of our time with normal curves.
Are all normal curves density curves?
Yes.
Mind blown.
All right, can I move my paper up, please? And thank you. All right, so we're going to look at a few other problems. We're not going to suppose, because IQ scores actually do follow a normal distribution. They have a mean of 100 and a standard deviation of 15. Now, the thing here is that we're going to use the 68, 95, 99.7 rule to answer this question. So I can ask you to use that rule. I can ask you to use your calculator. I will talk about table A, but honestly, that's the old school way, and the calculator is much simpler. But I will show you so that if you see it in the homework, you're not freaked out. But table A can be done by the calculator, so don't feel like you have to use table A. So we're going to show a picture. We want to find the percentile of a person who's got an IQ of 130. Percentile. What is the definition of percentile?
Better than or equal to 90.
Is it the percent below or the percent above? Percent below. So really, we're going to find the percent below 130, and that's the percentile for a person who scores 130. So it's normal, mean of 100, standard deviation of 15. So we have 100 here at the middle, then we have 115, 130, 145, 85. Oh man, that'd be 70, right? I'm much better at adding than subtracting. 70 minus 15, 60. Thanks, Molly. My brain just, I don't know. Add, multiply, divide, I'm great at, but subtraction I kind of suck at. All right, so we want to find the percentile for somebody who scores 130 on the IQ test. So 130 is right here. Percentile means the percent less than, so we want to find this percentage. Now, we could use the calculator, but we can also use our 68, 95, 99.7 rule. 68% of our data is between what two numbers?
78. No. 85 and 100.
85 to 115, one standard deviation above and below the mean holds 68% of the data.
We're trying.
And then 95% of the data is going to be between which two numbers? 70 and 130. Thank you, Seth. So between two standard deviations above and below the mean is 95% of the data. And then 99.7 is going to be between what two numbers here?
55 and 140.
Thank you again, Seth. 55 and 145. So 99.7 is between three standard deviations above and below. So, what percentile is a person at 130? Did you say 95?
No.
Is that what you said? I'm really bad at reading lips. That's why I asked for clarification. 95 is wrong. But is that what she asked if it was wrong, so I had to answer. I can't read lips.
97.5.
Be nice,
yeah, no,
Bianca.
that's wrong.
No, she went,
Hey, that's wrong.
and I thought I saw 95, but I also didn't want to be like,
It's too early for this.
too early? How is it too early? It's like almost 11.
I left
Exactly.
my house at like
Yeah, it's not after 11, so it's due.
So it's
So it's late compared to when
It
you
is-
left
it
your
is pretty
house.
late,
Yeah.
he's going.
I've been up for a while.
All right, Seth, what percentile are we at?
97.5%.
We're at the 97.5 percentile. Will you explain why it's that one, please?
Feel I did the math.
Because
Thanks,
if you were to consider everything else, that would be 5 more percent. Because 100 minus 95 is 5, and you don't want to count to the right of 130, and that's half of the 5%. So it's 2.5 more percent on top of 95%.
To paraphrase what Seth said, 95% is between 70 and 130. So that's between those two. That's 95% of the data. Which means we have 5% in our tails. Normal curves are symmetric. So if we cut 5 in half, that means we have 2.5% here and 2.5% here. And notice the shaded area below 130 is all that 95%, and then this tail as well. So somebody who scores 130 on their IQ test would be at the 97.5 percentile. Questions? Bless you. All right, what percent of people score below 90? We're going to draw a picture. We're going to find the z-score. I'm going to show you table A. And then I'm going to show you that the calculator gives you the same thing. But that way, if you're asked to work with a z-score table A, I've covered it so that you don't freak out and go, she never taught us this. All right, same normal curve. It's got a mean of 100, standard deviation of 15. I feel like my normal curves have gotten worse each time. They're supposed to get better.
That was pretty bad.
Not when it's bad. It's not even like even on both sides. I don't know. Ugh. We'll pretend it's even. All right, so the question is, what percent of people score below 90? So 90 is going to be closer to the 85 than the 100. And we're looking at below 90, so that's the stuff to the left. Now, we drew our picture. We're going to do a z-score calculation. How do we find a z-score? DJ?
It's x minus the mean divided by the standard deviation.
Thank you, DJ. We're going to take our observation, x, minus the mean, divide by the standard deviation. So we're interested in an IQ score of 90. The mean is 100. And the standard deviation is 15. 90 minus 100 is 10, divided by 15, so, sorry, 90 minus 100 is negative 10, divided by 15. It's going to give us, maybe if I can get the glare to go away, negative 0.6666666 forever. Don't get mad at me, Seth. How many decimals on a z-score?
4.
2. And when I show table A, maybe it'll make more sense. So we're going to round to negative 0.67. Now, it does say, and I purposely did this, it says use table A to find your answer. Table A takes z-scores and tells you the area under the curve that is less than that z-score. It's in the back of your textbook. I want you to be aware of it. I want you to know how to read it. But the calculator does all this same stuff. But I don't ever want it to come up on the AP exam and my students don't know what to do with it, so I always talk about it. All right. Here's table A. It's at the back. Table A is so big that it takes up 2 pages. So there's table A, and then there's table A continued. Okay. Notice that it tells us table A tells us the probability that is less than a z-score, to the left of z. So table A gives you the correct answer if you're looking at a problem like this. If we're looking at a problem where the area is to the right, there's an extra step. Going down the side are the z-scores. So we're going to find our z-score of negative 0.67, and then we'll get our area under the curve. Now, if you look at these z-scores on the side, they only go to 1 decimal place. the second decimal goes across the top. So we have negative 0.67. So we're going to find negative 0.6, and then we're going to go across so that we would have 7 as our second decimal. So this is negative 0.60, negative 0.61, 62, 63, 64, 65, 66, 67. So the area under the curve for the problem we just did is 0.2514. And now do you see why I say 4 decimals for area and 2 for z-scores, Seth? Because that's the way the table is made. So the area right here was 0.2514. Which tells us that about 25% of the time somebody scores below 90 on the IQ test. Am I off the screen?
No,
Alright, now we're going to do the same problem, but we're going to use the calculator. So Annika reminded us our calculator function is normal CDF. For the problem that we did in number 2, what's the lower bound? A really small number, negative 1e, 99. Thank you, Jillian. What's the upper bound? 90. What's our mean? And standard deviation. Thank you, ma'am. And then we put that into our calculator. Can I cover it up?
Yeah.
So second vars, number 2, negative 1e, 99, 90, 115. Everybody good before I hit paste? And we get 0.25249. So 0.2525 when we round. Which one do you think is more exact? Table A or the calculator?
Ours.
The calculator.
So why don't we use a calculator?
We can. That's what I'm saying. But like I said before, I'm preparing kids to take an AP exam, and if I didn't just teach it as here's what you have to do, then when they got to the AP exam and something came up, they wouldn't know what to do. So I just teach it as if you're all going to take it, which means I introduce table A, I tell you how to read it, but then I tell you, hey, the calculator works better, so use the calculator. But there are times on the AP exam they'll tell you you have to use it, and if you use your calculator and you put this answer, 0.2525, they'll know you didn't use table A because they don't match. So I show you guys how to use table A even though the calculator is quicker and better. Questions? All right. What score puts a person in the 99th percentile? We're going to show a picture. We're going to do our z-score calculation and then use table A. This time we're going to end up working backwards, which we'll see if you remember how to do that part too. Let's see. I guess I can squeeze it in there. That was a really bad dash, but whatever. Like I said, they seem to be getting worse, not better. Alright, 99th percentile. What information is that actually giving us? The area. So we're going to estimate, because we know from the 68, 95, 99.7 rule, 130 is the 97.5 percentile. So we're going to estimate that the 99th percentile has to be somewhere in between 130 and 145. Would you guys agree with me? Did you say no, Caleb?
I didn't pay attention.
Did somebody say no?
No one said.
He said sure.
Oh, you said sure. I could have sworn somebody said no, but maybe that was just me thinking you guys would
Anybody
second
feel
guess
you?
me. Yeah.
Wow.
Would you rather I blame you? Because I could do that. Alright, so I'm going to estimate there. Really, it doesn't matter where my line is as long as it's between 130 and 145. 99th percentile tells us that we have 99% in here. So we got our picture. We know the formula for a z-score is z equals x minus the mean divided by the standard deviation. Do we know our z? No. Do we know our x?
No.
No. This is where we would work backwards in chapter 2. And you can use table A to work backwards. We know the area, which is all these numbers here. The z-scores are on the outside of the table. So we're going to look for 99% in the area. Now if I look here at the very bottom one, it's 0.4641, which tells me I got flipped to the next page. So I always look on this first column first and get as close to 99 as I can. So I have 0.9861, 0.9893. So I'm going to work from here and go across until I find one that's close to 99%. Which one's closer? I'm going to zoom in a little so we can read it more clearly. Is 0.9898 closer to 99% or 0.9901? 0.9901. So that tells me that I have a z-score of 2.30123 or 2.33. So I know my z is 2.33. We don't know x, that's what we want to find. We know the mean is 100 and the standard deviation is 15. How do I solve for x?
Multiply by 15 and add 100.
Thank you, sir. We're going to multiply both sides by 15 and then add 100. Maybe. I can grab my calculator. 2.33 times 15, that's 34.95 equals x minus 100, and then when we add 100 to each side, we get 134.95 for our IQ score. Which, like we estimated, it had to be somewhere between 130 and 145. So our answer seems reasonable. Now, to work backwards using the calculator, what was that function called? Inverse norm. And we find inverse norm, same place as normal CDF. If you have the newer calculators, it'll prompt you for the area, which is the percent or the probability, and then your mean and your standard deviation. So we're looking at the 99th percentile. Biggest thing, make sure you change the area, the percent, to a decimal. So 0.99. Second bars, and then it's the third one down. Mean is 100, standard deviation of 15. Everybody good if I hit paste?
Yeah.
Nolan always says yes for me, thanks. So then, if you're working with the older calculators, notice you have to put the commas in between. And we get 134.8, well, if I round 0.9, 134.9. So this was 0.99, this was 100, and that was 15. So we get 134.9. May I borrow yours for a minute? So, some of you do have the left, center, right. We shaded to the left, so you would choose the left. If we shaded to the right and we're working backwards, you would choose right. And if we shaded in between two numbers, you would choose center. So if you have that question, it's just where the shading is. Is it to the left of the number you're interested, to the right, or between two certain numbers? Questions? Can we flip?
Yeah.
Nolan says yes. Thanks, Nolan. Yes, ma'am.
What's the difference between the z-score and the z-score and the inverse norm?
So the z-score is how I would have to work backwards to find the value here. Inverse norm skips that step. Z-scores, remember, are if you have a normal curve with a mean of 0 and a standard deviation of 1. What that really tells me is that somebody who's at the 99th percentile is 2 1/3 standard deviations above the mean. Which, here's our mean. We went 1, 2, and because we were estimating, I made mine at like 2.5. But really, somebody who scores in the 99th percentile is going to be 2 1/3 standard deviations above the mean. And that's all a z-score tells us, how far away from the mean we are if we were to standardize it. Other questions? You lied to me, Nolan. You said I could flip my paper.
Could have flipped it. You don't need to look at it.
All right. Let's see, can I make it fit? All right, so this says the normal distribution with a mean mu equals 6.8 and standard deviation sigma equals 1.6 is a good description of the Iowa Test of Basic Skills, or the ITSB, vocabulary scores of 7th grade students in Gary, Indiana. We're going to call the score of a randomly chosen student X for short. We want to find the probability that a randomly chosen student, X, has a score that is greater than or equal to 9, and we're going to interpret the result. So the first thing we're going to do is draw a picture, and I did use table A to find the probability. Yeah, why don't you? Well, no, you don't have your books. I was going to say, yeah, let's practice, but draw a picture, use your calculator. If you have a book underneath you, you might want to practice using it. It doesn't have a page number.
Very, very bad.
T1 at the Nope, see, no page number. But if you flip the page, it says T2 at the top. So I said T1, but no, it's way at the back. Draw your picture, use your calculator to find the probability that a randomly selected kid has a score of 2.
Can I go to the bathroom?
Uh-huh.
Wesley's.
I'm trying to call my elbow.
It is kind of yes, everything is math.
Oh, absolutely.
Sorry.
So you're doing science if I new types of science?
Hold on, start again.
In science if I new types of science, you're doing like the, is that the same thing as math? You find new math or you mention new math?
Really at this point, I mean, yes, they're finding new math, but a lot of it is these theorems and ideas and problems from the past that were never truly proven, and you're just kind of like, oh yeah, we'll get there eventually. Mathematicians like solve really like old problems that never been solved. So,
I had asked my dad this week, he said, invented, if you're a math teacher, you should do it.
I mean, something they had us debate. And I was sharing my degree. Well, if it was wrong, I would
Oh yeah, exactly like you did over there.
Okay,
That's
you
wrong.
know.
That's wrong. Oh, that's not right.
Wrong.
This is wrong.
Emma, this is correct. Good to
No, I'm having a conversation.
Yes. Emma is gonna put it on the board for us.
No, I'm just putting my essay today. I finished it in 6 pages. Yeah, it's really bad. I mean, she's really like, I try to read it and I'm like, what am I talking about?
Go, go.
You just think that's fine.
What's your answer?
Just the top part or like the
Everything you put.
like. Oh, that's not bad.
How do you get the little E? You hit second, comma. Not happy.
I just think it's
Even more not happy.
Yeah, I would write that paper for something else. Like, it's stupid that my senior paper's about it.
Which one?
Everything goes to the more you get off the it's not stupid. Yes, it's stupid.
It is stupid. A book report for your senior paper?
She's like, you can turn it in. I was like, I didn't try. I have one thought about
It has one of your
pages and be happy about it. Like, it's just not gonna happen. I don't know about that. Like, oh, she's rebellion of the rebel. I was like,
way too small.
I'm gonna start
They make real
They're
cheese.
actually it's actually really good. But it has a white stuff too.
Oh, it's white cheese.
It's not like
It's
the
the way you said that, I thought we were dissing on the fact that it was white cheese.
American or cheddar.
Cheddar. What about the cheese that has orange and white? I thought you said you didn't know the names.
So she lied.
She is lying. All right, Emma drew the picture, labeled it beautifully. She even found the z-score, even though I said go ahead and just use your calculator, but I do love that she found the z-score there for us. And then when you put it in the calculator, you get 0.0845. If you rounded to 0.0846, that's fine as well. If you haven't already, try the bottom one. Same idea, but this time find the probability that x is less than or equal to 4. And use the calculator, even though I put table A on there again. I didn't think through that we wouldn't all have the book with us. I suppose I could have printed the table, but... Oh, reminding me of that. We would say that a randomly chosen student gets a score of 9 or higher.
Do you miss Gabe as well? Do you miss Gabe?
Yeah,
You miss Gabe?
yeah.
Yes.
They don't ever know if they want.
He's still on my roster. He's not coming back.
I actually
Ah, he's at Disney.
Oh.
Why?
Well, the way you said that, asked if I missed him, I thought maybe he was like dropping being my aide or something.
Oh no, it's just
Like, really? Who drops an aide class?
yeah.
I am gonna interrupt because Miranda reminded me that up here it says to interpret, and then I didn't actually have you guys interpret. So the way we would interpret this result, again, I'm sure you can make it sound better than me, but I would say something like a randomly chosen student scores 9 or higher about 8.45% of the time. And then, if you will, keep working on C for me, please.
Oh, did you get to like weekly like chapter quiz or something? Oh, watching a movie, I love it. Yeah. Sad. Oh. No, like the blood, you suck. You liked you? It's weird. It's weird, exactly. It is weird. You like witches? Exactly, that's what I'm saying. It's all about, I don't know. It's weird, man, I'm just telling you. Bro, there's like a 6-year-old man dating like a 12-year-old girl in that. It's weird. That's what? Huh? Oh, really?
She's the mom on
Oh, who's she playing? Yeah. She's evil? They're all evil.
There's so many in there.
Yeah, that's what I'm saying, dude.
There's a whole group of women.
Is she like girl that... Oh, the Abigail girl.
Oh.
The Abigail? Yes.
the one who gets the heart.
Yeah. That's what I'm saying, the 12-year-old.
Oh, it's an Abigail.
Yeah, Abigail. That is Abigail. Dude, that is her.
Honestly, 2 years.
Yeah, maybe it is, because I'm reading it right now. We're watching the movie.
I like your inverse norm.
What's not I'm starving, actually.
I'm starving too. My tummy's
Really? What do you have, peanut butter? And bananas?
peanut butter. I knew someone was wrong. Can I drop you? Well, actually,
Well,
we All right, Nolan's gonna do C for you guys.
It's like every day.
So hungry.
What do you have for lunch? Did you get peanut butter?
I have an orange. I have an apple. I have string cheese.
Oh, damn.
I do have string cheese.
I love Variables.
I love string cheese too. Almost as much as I love peanut butter.
You actually peel it apart.
Of course.
If you eat it whole after me,
Of course
That
I
tastes
peel
nasty.
the string cheese.
I don't have time. How weird that is. I was like, that's like uncomfortable.
You just take bites?
Yes.
that is disgusting.
The best way to eat string
And then he
cheese.
starts like,
I
I don't have time. I don't have time to pull apart the string cheese.
Yeah.
If I have time, you have time.
String cheese for a reason. Yesterday, I ate a piece of bread with butter on it, and I didn't. It's like if you want to eat cheese,
Jill.
like red ones. I'm also mentally ill, so it's
Yeah, you get those.
it got slapped though.
You get string cheese.
Tastes good.
Here's the string cheese right here.
Three cheese, that was it? Wait, what did you
No. All right. Before you pack up, notice that Nolan also found the z-score for us. Thanks, Nolan. It's negative 1.75. Hopefully you got the area 0.0401. You have your yellow sheet, but the homework's also on here as well.
It's Friday, right?
It is Friday.
Little.
What'll